You all know that the board paper of the first term has 3 sections, section A, B, and C. In section A, we have 20 questions and you have to answer 16 questions. First question, let R be a relation on N defined by x plus 2y equal to 8. The domain of R is x plus 2y is 8, so it is easy to write for x, 8 minus 2y. If y is 1, x will be 8 minus 2, 6. If y is 2, x will be 8 minus 2, 2s are 4, 4. If y is 3, x is 8 minus 2, 3s are 6, 2. If y is 4, x will be 8 minus 8, 0. But it doesn't belong to the natural number set. So we should not take y as 4. Let us write the relation R in the tabular form. If x is 2, y is 3. If x is 4, y is 2. If x is 6, y is 1. We have to write the domain of R. Domain is set of all first elements of this relation. Therefore, the domain of this relation is 2, 4, 6. The answer is C subdivision. Second question. The number of all possible matrices of order 3 by 3 with each entry 0 or 1 is. It is a 3 by 3 matrix. A11, A12, A13 first row elements. These are the second row elements. And the third row, A31, A32, A33. Totally we have 9 elements. And for each we have 2 options. We can fill it up with either 0 or 1. So 2 ways for each position. So we will have total number of ways 2 into 2 into 2, 9 times, which will be 2 raised to 9. The answer is 512. D option is the correct option. Question 3. The domain of the function f of x, which is sine inverse of root of x minus 1 is. We know that the domain of sine inverse of x is minus 1 to 1. That is, x lies between minus 1 and 1, including minus 1 and 1. But here we have root of x minus 1. Let us square all the terms. So negative values also will become positive. By squaring, these negative values also will become positive. So 0 less than or equal to x minus 1 less than or equal to 1 square is 1. Let us add 1 throughout. 0 plus 1 is 1. X minus 1 plus 1 gives us x. And this is 1 plus 1, 2. Closed interval 1, 2. A option is the correct option. Question number 4. The corner points of the feasible region determined by the following system of linear inequalities: 2x plus y less than or equal to 10, x plus 3y less than or equal to 15, x and y greater than or equal to 0 are 0, 0, 5, 0, 3, 4, and 0, 5. The objective function z is px plus qy, where p and q are positive numbers. Condition on P and Q so that the maximum of Z occurs at both 3, 4 and 0, 5. Let us calculate Z values at these 2 points. At 3, 4, X is 3, Y is 4. So Z will be 3 times P plus 4 times Q. And at the point 0, 5, substitute X as 0 and Y as 5. Z becomes 0 plus 5q, and they give the same maximum value. So these two z values should be the same. 3p plus 4q is equal to 5q. 3p is 5q minus 4q is q. So the correct option is q equals 3p. D. Question number 5. The slope of the tangent to the curve x is equal to t square plus 3t minus 8 and y is 2t square minus 2t minus 5 at 2 comma minus 1 is. These are parametric equations. Let us first find dx by dt and dy by dt. Divide to find dy by dx. Dx by dt is 2t plus 3 and dy by dt is 4t minus 2. Let us now calculate dy by dx, which is dy upon dt divided by dx upon dt. So dy by dt should be in the numerator. Okay, at 2 comma minus 1, the point given is 2 comma minus 1, that is x and y values are given. We need t value. Let us substitute the values of x and y in the given parametric equations. 2 is t square plus 3t minus 8 and y is minus 1, which is 2t square minus 2t minus 5. We get the quadratic equation t square plus 3t minus 10 equal to 0. We will factorize t plus 5 and t minus 2 is 0. Similarly, 2t square minus 2t minus 4 is 0. Dividing throughout by 2, we get t square minus t minus 2 equal to 0. Let us factorize t minus 2 times t plus 1. Here we get the answers for t as minus 5 and 2, and here we get 2 and minus 1. The common solution will be the final answer for t. So t should be 2. Now we will find dy by dx when t is equal to 2. So it is 4t minus 2 upon 2t plus 3. Let us plug in the value 2 for t. 2 4s are 8 minus 2 divided by 2 2s are 4 plus 3. 6 over 7. The correct option is B. Question 6. The function f of x is 4 minus x square upon 4x minus x cube. We have to check at how many points it is discontinuous. Let us factorize the denominator. We can take x common, 4 minus x squared. The denominator should not be 0. For continuity, we know that limit extending to some value of f of x should be equal to f of a. F of a should be defined. Here, the denominator should not be 0. That is, x into 4 minus x squared should not be 0. So x is not equal to 0 and 4 is not equal to x squared. That is, x is not equal to plus or minus 2. At these 3 points, when x is 0, 2, minus 2, f of x is not defined. Therefore, it won't be continuous at these 3 points. So the function is discontinuous exactly at 3 points. C option is the correct answer. Question number 7. Again, parametric equations we have, but second order derivative we have to calculate. Second order derivative of parametric equations is an important question. Let us calculate dx by dt, which is 2a. Differentiation is so simple here. dy by dt is 2at. Therefore, dy by dx will be, write dy by dt in the numerator and dx by dt in the denominator. You may go wrong by dividing the other way around. Do it carefully. This is 2at divided by 2a. The answer is t. This is the first derivative. But we need to calculate the second derivative. dy by dx is t. Now we have to do the differentiation with respect to x so that we get d square y by dx square. But on the other side, we have t. We have to differentiate t with respect to x. Dx over dt is 2a. Therefore, dt by dx will be reciprocal of that, which is 1 upon 2a. A subdivision is the correct answer. Here there is no x to substitute. It is a constant. So x is equal to half is of no use. Question 8. If A and B are two matrices such that AB is equal to A and BA is equal to B, then B square is equal to. So we have to calculate b square. We will take this equation, ba equal to b. B times, let us substitute for a from the first given equation, which is ab equal to b, because it is given that ab is a. Let us use associative property. Change the brackets. So in this we have used the associative law. Now BA is B by the second equation, because BA is B given. So we get B square equal to B. So the correct option is A. Question number 9. If B is a non-singular matrix, what do you mean by a non-singular matrix? Determinant value is not 0. And A is a square matrix, then determinant value of B inverse AB is equal to. Determinant of B inverse AB can be written as determinant of B inverse into determinant of A into determinant of B. Using the property determinant of A into B is determinant of A times determinant of B. And we know that determinant of B inverse is determinant of B the whole power minus 1. That is 1 by determinant of B. This is 1 upon determinant of B into determinant of A into determinant of B. We can cancel these two. Therefore, the answer is determinant of A. C subdivision. Question 10. The function f is defined from 0 to infinity to r. So the first set is the domain of the function. The second set is the real number set, which is the codomain. F of x is given as x upon 1 plus x. So we have to check whether it is 1, 1 and on 2 or not. So to check whether it is 1, 1, we take f of x1 is equal to f of x2, and we have to arrive at the result x1 equals x2. This is x1 upon 1 plus x1, and this is x2 upon 1 plus x2. Let us cross multiply. X1 plus x1 x2 is equal to x2 plus x1 x2. So we get the answer x1 equals x2. Therefore, it is a 1, 1 function. Now to check whether it is onto function or not, see this ratio. And the domain of this function is closed interval 0 to infinity. X takes only positive real values including 0. Therefore, this will be greater than or equal to 0. And the denominator is bigger than the numerator. Therefore, this ratio will be less than 1. So the range of this function is 0 to 1. For all other real values, there are no pre-images. Therefore, it is not an onto function. It is 1, 1, but not onto. B option is the correct option. Let's do question 11. The function f of x equal to cot inverse of x plus x increases in the interval. Let us find f dashed of x. Derivative of cot inverse of x is minus 1 upon 1 plus x square. For tan inverse of x, it is plus 1 upon 1 plus x square. And derivative of x is 1. Let us take LCM. We get x square upon 1 plus x square. Since we have x square term, we know that x square is greater than or equal to 0. Therefore, this ratio is also greater than or equal to 0. Whatever the value of x is, f dashed of x is greater than or equal to 0. Therefore, f of x increases in R, the real number set R. Therefore, C option is the correct option. Question 12. The solution set of the inequation 2x plus y greater than 5 is. Let us draw the line. A rough figure will do. Let us draw the table. We will take the equation to draw the line equal to 5. So if x is 0, y is 5. If y is 0, x is 5 upon 2, which is 2.5. A rough sketch will be enough. This is 5 and this is 2.5. And the inequality given is 2x plus y greater than 5, strictly greater than 5. There is no equal to sign. When there is no equal to sign, we have to use a dotted line. That means the points on this line are not included in the solution set. Let us shade the region. Let us check with 0, 0. So 0 plus 0, 0 greater than 5 is not true. That means 0, 0 doesn't satisfy the condition. Therefore, the solution region is away from the origin. A option is half plane that contains the origin. No, it doesn't contain the origin. Open half plane not containing the origin. Yes. B option is the correct option. C is wrong because whole xy plane except the points lying on the line. It's not whole of xy plane. Okay, B option is the correct option. Now question 13, f is from 2 to infinity to x, be defined by f of x is equal to 4x minus x squared. It is a quadratic equation. It's a parabola, but only half parabola because it is 2 to infinity. Then f is bijective. Bijective means it is 1, 1 and onto. Since f is an onto function, x is the range of that function. Let us take f of x as y. I'm changing the sign throughout. Minus y it becomes. Let us complete the squares. X minus 2 the whole square minus 4 is minus y. Because this expansion gives x square minus 4x plus 4. So to cancel this plus 4, I have written minus 4. So that we get back the original expression x square minus 4x. X minus 2 the whole square is 4 minus y. X minus 2 will be root of 4 minus y. We don't put plus or minus sign because x minus 2 is greater than or equal to 0. Because the domain is 2 to infinity, no? So only plus sign should be written here. Therefore, x is 2 plus root of 4 minus y. Now, since 4 minus y is under square root, 4 minus y should be greater than or equal to 0. That is, 4 is greater than or equal to y. That means y can take any real value which is less than or equal to 4. So the option is C, minus infinity to 4. Question 14. Evaluate tan inverse of tan 3 pi by 4. We cannot cancel tan inverse and tan because 3 pi by 4 doesn't belong to the principal value branch of tan inverse, which is minus pi by 2 to pi by 2 open interval. Therefore, we will write 3 pi by 4 as pi minus pi by 4. 3 pi by 4 is a second quadrant angle, which can be written as pi minus pi by 4. Take LCM and check. We get 3 pi by 4. Now let us use tan pi minus theta formula. For pi, we don't change the ratio. Pi minus theta is in the second quadrant. In the second quadrant, tan is negative. So minus tan theta. We get tan inverse of minus tan theta is pi by 4. This can be written as tan inverse of tan of minus pi by 4. Or we can use this formula also. Tan inverse of minus x is minus tan inverse of x. That way also you can write. Now tan inverse and tan could be cancelled because minus pi by 4 belongs to the principal value branch of tan inverse now. The answer is minus pi by 4. Option B is the correct answer. Question 15. If A is a singular matrix, we know the definition of a singular matrix. Singular matrix means determinant of A should be 0. Then adjoint of A is singular or not, we have to check. Okay. We know that determinant of adjoint of A is determinant of A whole raised to n minus 1. This is an important formula. Now determinant of A is 0. So 0 raised to any number is 0. We get the determinant value of adjoint of A also as 0. Therefore, adjoint of A is also a singular matrix. B option is the correct option. Now question 16. The value of b for which the function f of x equal to 5x minus 4, 0 less than x less than or equal to 1 and 4x squared plus 3bx where 1 less than x less than 2 is continuous at every point of its domain is. Let us find LHL and RHL at x equal to 1. So left hand limit will be limit x tending to 1 minus. For 1 minus, we have to use less than 1 definition, which is 5x minus 4. It's a polynomial. Polynomials are very easy to solve, direct substitution of the limit value. So 5 times 1 minus 4, which is 1. Let us now do RHL, limit x tending to 1 plus. For 1 plus, we have to use greater than 1 definition. X is greater than 1 in the second polynomial. 4x squared plus 3bx. Limit of a polynomial is very easy. Direct substitution of the limit value. Let us substitute x as 1. 4 plus 3b. And it is continuous everywhere. At 1 also the function is continuous. So LHL must be equal to RHL, from which we can get the value of b. b is minus 1. A option. Only one unknown quantity is there in this question. It's a simple question. Let's go to the next one. 17th question. Y is under root sine x plus y. This equation is an implicit equation. X and y are mixed together. To make our differentiation easier, we will square both the sides. Y square is sine x plus y, so that we can remove the root sign. Now let us differentiate with respect to x. Power has to be differentiated first, then y has to be differentiated with respect to x, which is dy by dx. Derivative of sine x is cos x, and derivative of y is dy upon dx. Let us collect dy by dx terms on the left hand side. 2y minus 1 equal to cos x. Therefore, dy upon dx will be cos x upon 2y minus 1. D option is the correct option. Question 18. If R is a relation on the set A, 1, 2, 3, and the relation R is given in the tabular form 1, 1, 2, 2, 3, 3, then R is, of course it is reflexive because A has only 3 elements, 1, 2, 3. For all these 3 elements, we have AA form, 1, 1, 2, 2, 3, 3. Therefore, the given relation is reflexive. Okay, let us check whether it is symmetric or not. 1, 1, 2, 2, 3, 3. Even if we interchange, the elements are the same. So they belong to R. Therefore, it is symmetric also. Now, transitive condition. The transitive condition is a conditional statement. If A, B, B, C belong to R, then AC should also be there in R. This is the definition of the transitive condition. If you don't have elements of this form, that is, this becomes false. The whole condition becomes true. So when you don't find 2 elements of this form, AB, BC, remember it becomes a transitive relation. Okay, very important point which you should remember. Therefore, the given relation is transitive also. So all 3 options are correct. D option is the correct answer. Question 19. Out of the given matrices, choose the matrix which is a scalar matrix. Let us see what is a scalar matrix first. Scalar matrix should be a square matrix. So definitely these three won't be there. These are not square matrices. Number of rows and columns are not the same. So this is the only option left. Okay. Now scalar matrix definition is the diagonal element should be same constant C, any constant, it can be any real value. Whereas the non-diagonal elements should all be zeros. Okay, this is the definition of a scalar matrix. Here, the diagonal element, the constant is also zero. Therefore, the answer is A. A is the scalar matrix. Question 20. This is the last question of section A. Differential coefficient of secant tan inverse of x. Let us first simplify this function and then we will do the differentiation. If you do the differentiation directly, again you have to simplify it. So let us simplify first and then we will do the differentiation. Secant of tan inverse of x. X can be taken as x by 1. I can easily change tan inverse to secant inverse. Tan is opposite by adjacent, so we can get the hypotenuse. Secant tan inverse of x is secant inverse of hypotenuse divided by the adjacent side. Now secant and secant inverse could be cancelled. Here this is a value, root of 1 plus x square is a value, so no checking required. Only if you have secant inverse outside and secant function inside, the angle should be in the principal value branch. Here this is not an angle, this is a value, so we can cancel secant and secant inverse. The answer is root of 1 plus x square. This is only the simplification of the given function. Now we are going to differentiate. So dy by dx will be, we can write this as power half. Power has to be differentiated first, keeping the base same. And then the base has to be differentiated with respect to x. The answer is x upon root of 1 plus x square. The correct option is D.